Hi there. In this video we're going to take a quick look at how we can use an equation to find the area of a circle. Figuring out the area of a circle can be tricky at first because we're used to finding the area of things that have straight edges, not things that have curved edges like circles do. Now certainly we could measure the height of a circle and the width of a circle, and we could calculate a measurement that would be a lot like the area of a square. But what's problematic about that is that wouldn't account for all these sections here where the circle does not actually touch. At best we would have an estimate and not a very good one. But some smart mathematicians early on figured out a way to solve that. They might have started by looking at a square. We know that we have a set area for a square, and if we happen to cut that square into pieces, let's say 4 pieces as we did here, those 4 pieces still add up to the original area of that square. Even if I move them into a long rectangular shape, even if I set them up into a less conventional shape, if I find the area of those 4 squares, they will equal the area of that original square. Got them thinking, what if we cut a circle up into pieces? Can we make another shape that we already know how to find the area? What those mathematicians realized is that if they chopped the circle into many different slices, those slices started to become very triangular in shape. And then if they arranged them in kind of a zigzag pattern, they started to take the shape of a parallelogram. The more thinly they cut the pieces, the more and more those pieces resembled a simple parallelogram or even a rectangle. The good news about that was we already know how to find the area of a parallelogram. We simply find the base times the height. Very straightforward. So what they did is they said, okay, well, let's look at the pieces that are making up this parallelogram and get to use that to find the area of the circle. Now, if you take a look at how I built my parallelogram here, I didn't use the whole circumference of the circle. I only used half. Half is on the top, half is on the bottom. So, the base of the parallelogram is half of the circumference. The radius of the circle is the height. That's the distance from the center to the outside, and that happens to be the same length as these pie pieces here. So, the base of the parallelogram is 1/2 of the circumference, and the radius of the circle is there. So 1/2 circumference times the radius would give me the area of my circle. Now here's where these mathematicians really showed some genius and really helped us out, because they realized that this formula they were looking at still had a lot of variables that had to fill in. To figure out the area, I needed to know the radius of the circle and the circumference of the circle, which meant that I had to do a fair amount of work. I either had to figure out the radius and then do some calculations to figure out what the circumference is, or if I already knew the circumference, I'd have to break it down until I figured out what the radius is. They wanted to simplify because mathematicians are nothing if not efficient. Here's what they did. The mathematicians looked at the formula they came up with, this one here, and said, I bet we can find a way to get rid of one of these variables. That'll make it easier to solve this equation. What they wisely thought is that, hey, we already have a formula for circumference. That formula is this formula right here. The circumference is 2 times pi times r. That might seem complex to stick a whole new formula inside of the formula you're already building, but it does one really important thing. It takes the variable c out of there and it replaces it with 1 and 2 r's. Those r's are common. That radius is the same value. So all of a sudden we've got rid of one thing. We don't need to know the circumference anymore. All we need to know is the radius. They did some algebraic calculations to break it down to its simplest form. They did 2 multiplied by 1/2, which we know is 1. They kept pi because that didn't change. And they said r times r, well, that's r squared right there. And what they did is they came up with this key formula that we see before us. Area of a circle equals pi times radius squared. That's actually a huge improvement on this formula because we don't need to know the circumference anymore. We just need to know the radius. So let's put it into action here. We have a circle here with a radius of, let's say, 6. Now, with the other formula, we would have had to find the circumference all the way around as well. But with this formula, the simplified version, we don't. We already have everything we need. We know that the area equals pi times 6 squared. And hopefully if we're using BEDMAS, we remember to do the 6 squared first because it has an exponent. And we know that it is pi times 6 times 6, which is 36. That equals 113. So that we know the area of this whole circle is 113 square units. As we've seen with other videos, this is also really helpful because we can move backwards. Let's say someone hands you a circle and you know that the area of the circle equals 56. What you can do now is you can work backwards to find the radius, and if you find the radius, you can easily figure out the diameter or the circumference. So, let's say that we want to figure out the diameter. Well, that means that we have our formula, area equals pi r squared. So, we know our area is 56, so our formula now looks like 56 equals pi r squared. Then I can start the process of isolating the variable r. First thing I'm going to do is divide both sides by the value of pi. That will eliminate pi and get just r squared on one side of my equation. So what I end up with is 56 divided by 3.14, which is the value of pi, which equals 17.8. So now my equation looks like this. 17.8 equals r squared. How do I get rid of my exponent? Well, a little trickier, but if we think about it, not too challenging. This exponent means that I'm saying radius times radius, r times r. The opposite of that is when I divide the radius by that same number. So I want to find the square root of that number. So the square root of r squared is simply r. That means I have to also find the square root of 17.8. So the square root of 17.8 is 4.2. And the square root of r squared is r. Look at that. Radius equals 4.2. Now remember I said we wanted to find the diameter. Easy now. The diameter is simply 2 times the radius. So my diameter would equal 4.2 multiplied by 2, which equals 8.4. Hopefully you realize now that I could take this diameter and easily find the circumference of the circle as well using the other formulas that we already know. So it's really helpful that I can use algebra to find that missing number and isolate it. The trick, of course, is always doing the opposite. If you think about it, going back up to the top here I had multiplication, pi times r squared. Well, how did I get rid of those things? I divided, kind of like the opposite of multiplication. Then I had a square exponent. What's the opposite of an exponent, a square exponent? Finding a square root. That divides that number by its same self. So that's what I wound up with here. Okay? If you keep that in mind, finding the opposite, then you can usually use these equations to work backwards. Okay, ready to give it a try? I'll give you a question, pause, and then come back and we'll solve it together. So let's say you have a circle with a diameter that equals 18 centimeters. Use that and tell me how many square centimeters that circle is going to be. I'll see you in a minute. Okay, let's see how you did. I hope the first thing you did is write down the formula for area of a circle. A equals pi r squared. It's really helpful to have it there so that you can kind of take a look at it as you go through, and sort of helps you catch anything that you might need. Just sometimes when students just try to keep the equation in their head, they maneuver things around and make small mistakes. This can hopefully prevent that. Now, the next step I hope you did is you realized that you needed to find the radius. Hopefully what you remembered is that diameter is twice the radius. So to get this number, the radius, we would have to cut 18 in half by dividing by 2. So that means the radius equals 9 centimeters. Now we're really on our way. The area formula can now be filled in to say pi multiplied by 9 centimeters squared. Okay? Keeping in mind bed mass, we have to continue using our exponent first. So the formula continues, pi times 81, and then we do our final step, and that equals 254.3 centimeters squared. Really important that I remember we're talking about area, and because I use the exponent here, then it's definitely going to be centimeters squared. There it is. Not too bad at all. If you were given a different measurement, like the circumference, you'd have a few more steps, but ultimately you could use the expression, say, circumference equals 2 pi r, and you could break it down until you got simply a value for r. And then you'd be able to plug that value in, and again, you could find the area. All right, good luck.